Hi guys, this is the Innovative Minds Twitter. So in this video, we are going to work with October-November 2022 MIP 2602. Right, without wasting time, let's get to today's video. First thing guys, a group of students who were timed in their efforts to complete an F1 concession task for a certain module. The time in seconds of 20 students are summarized in the following stem and leaf plot. Right, stem and leaf plot, or we can say stem and leaf diagram. So use the data in the stem and leaf to answer the question 2.1 to 2.10. Are the data discrete or continuous? Explain your answer. Right, in my view guys, this data is discrete. Why I say so? Let's start with, we're at question 2.1. The data is discrete. It's discrete. Why? It is because it shows an individual values. Yes, it shows individually, not in a group. So it shows individually. Hence, it is not continuous. So it shows what the reason will be. It shows individual values. You will write it shows individual values and it's not continuous. That's what you can write them. Actually, you need to differentiate. Go in your study guide, study the difference between discrete data and continuous data, numeral data, and all those types of data. That will help you to work out such question in an exam. Right. Okay, without wasting time, let's go back. We are at now 2.2. Which graph can best display data of this kind? Explain your answer. Let's put that into practice. So we have 2.2. So the data that will be best will be a histogram. Why Mr. Richard prefer a histogram? It is because you can be able to differentiate the time values, intervals, as well as frequency. You can be able to differentiate the frequencies, time values, and intervals. Yes, because it deals with that, right? So histogram will be the best. So also study the different types of graphs in your study guide. It's there. They can show you. Sometimes they can ask you about the bar graph. They can ask you any graph. So go and study those graphs, right? So without wasting time, let's get to 2.3. Is it 2.3? Yes. At 2.3, answer the following equations based on okay, we are done with that. Let's go to 2.3. Answer the following question based on the stem and leaf plot on the figure 1. Calculate the mean to 3 decimal places. We need to find the mean. So it will be best to use a calculator if you can, right? Or you could add all these numbers, meaning that I'm going to say 41 plus 45 plus 46 plus 47 plus 48 plus 49 plus 50 plus 51, 52, and so on and so on, and divide by 20, because mean it's the sum of data divided by the total number of data. So you can be able to get your mean. So let's see if you are going to use a calculator. So in this case, let's say I'm using a KGFX. I will go to mode setup, press 2 stats, press 1 variable, because we're dealing with one variable here. So let's see, what are we having there? We have 41. So we are going to insert those things. We have 41. We also have 45. We also have 46. We also have 47. We also have 48. We also have 49. Okay. After 49, what follows? It's these numbers are from the stem and leaf. What follows? It's 50 and 51, 52, 54. What follows? It's 55. Then 56, 58. 58 is a repetition in 58. Then we have 60, 63. Then we also have 63 again, guys, here. So as well as 65, 67. Okay. Then lastly, it's 80. Okay. So when you're here, they're looking for the mean. Just press AC. Then press Shift. Then there's a button written stats. You'll press that button stats. Then because we're dealing with variables, press variable. Let's check how many of the learners, of the students are here. So there are 20 students in this data, which was true. So let's go Shift stats. Then for X bar is the mean. This one, it is the one that is the mean. So when you write, remember we're at 2.3 to 0.3.1. So the mean, which is represented by X bar, will be, let's press 2 there, will be 55.4. But they said in 3 decimal places. Just say Shift, mode setup, then press 6, which is fix. How many decimal places? 3. They said 3. Let's repeat. They said 6, then 3 decimal places. So you're gonna press 3 decimal places. So in other words, it's gonna be 55. 55. We need to follow the instruction, guys. 55,400. That would be the solution in this case. Okay, then now let's go back. Yes, now we are going to calculate the median. But how can we calculate the median without arranging the data into a standard form? Let's put that into practice. Okay, so let's do this. We have 2.3.2. So the data, it's gonna be 41, as well as 45, 46, 47, 48, 49. Then we have 50, 51, 52, 50. All right, we also have 51, 52, 54, 55, 56, 58, 58. Then we have 60, 63, 63. Then we have 65, 67. What do we have again? 67, yes, I guess that's the end of it in terms of 60. Then we have 80. Okay, so we need to find the median. To find the median, we will calculate the median is the middle data. So meaning that when you're working with the median, it's the same as let me get rid of this. So the median is half of the data. So you're going to say half of the data, 20 plus 1. This is the formula for finding the median. So meaning that the median, okay, the median is 10,5. So it's at 10,5. So you're going to count 10. 1, since it's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Also the other side, also going to count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So meaning both of this, we will add them. So it's going to be 54 plus 55 divided by 2. So let's just go 54 plus 55. Okay, the median, they didn't say anything in terms of, so that will be 50. They didn't say in terms of rounding, so we leave it as the way as it is. So it's gonna be 54,5. That will be our median. In this case, median will be 54,5. 5. Let's go to 2.3.3. Right, let's not waste time. Let's put this into practice. Then they said, what is the difference between unimodal and bimodal? The difference between unimodal, this is what you should understand, guys. Right, the difference between unimodal is that they have clear peaks, or they have what you could just say they have clear, you could say clear peaks or modes, that's how it is uni. And there's that meaning that unimodal, meaning here they can be one mode. In other words, uni means one, so they can be one mode. So whereas at bimodal, it means there are two, they can be two or more peaks or modes, or we could say modes. That's what it's bimodal. So those are the differences between the two, right? So let's not waste time. Let's go. We are at 2.3.4. Are the data in the scenario unimodal or bimodal? So in this data we have two modes, meaning that this is bimodal. So we have two modes that appear here. As you can see, there is 58 that appears twice here. There's also 63 that appears twice, making this making this data to be bimodal. So the data, it's bimodal. 58 and 63 appear twice. It appears twice in the data set. So that's the solution at 2.3.4. Now guys, we need to go to 2.4. We need to calculate now the variance. Right, to calculate the variance, we'll use the same techniques. So the variance is the square of standard deviation. It's the square of standard deviation in the simplest term. So let's put that into practice. So let's say we have 2.4, 2.4.1, little bit of light, 2.4.1. So let's use the same data that we have been using. So we're going to say mode setup. The variable is 1, so let's put 41. The arranged data that we've put: 45, 46, 47, be careful, 48, 49, okay, I was careful there. Then it goes to 50, 15, 51, we have 52 again, 54, 55, 56, 58, 58. Then we have 16, 63, 63, 65. Then there's also 67. Lastly, it's 80, okay, which is the 20th student. Then you press AC, shift, stats. Then you're going to choose variables. So we are going to take 3 as the standard deviation. Remember, the variance is the square of the standard deviation, so you have to square this, then making the variance to be 80. So we could just say variance, it's 80.74 seconds. Yes, 80.74 seconds. Right, they also said 3 decimal places. Wow. So we just say shift 6 there, 3. So that means it's gonna be 740. It's 80, 740. Then the question that follows after that, it's the standard deviation. The standard deviation. Let me not put too much light there. The standard deviation at 2.4.2. The standard deviation, guys, we are talking about the square root of the variance. Is the square root of the variance, meaning that in this case we are going to root this. So the standard standard deviation will be 80,740. Let's see what we get under standard deviation. So we take the answer that we've calculated there, put the answer. So it's 8,986. So the standard deviation is 8,986. That's the standard deviation at 2.4.2. Interesting. So let's go to 2.4.3. Calculate. We need to calculate the upper quartile. The upper quartile, it's the 3/4 of the data. So meaning that since it's a 3/4 of the data, let me clear this. Since it's the 3/4 of the data, remember how many students we have? We have 20. So it's going to 20 using a formula. For Q3 or upper quartile, you're going to say 3/4 n plus 1, where you're going to put the number of students and add it by 1. So it's gonna be plus 1 there. So 15,75. The 15,75 will be our Q3. Let's calculate. 1, 2, 3. Okay, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17,75. Somewhere here. Let's calculate, because already here at 40, where we already calculated the median. Where was our median? Our median, remember, we did got it at did I write it there? That was 54,5. Our median at 3.2.4. At 3.2, our median we got 54,5. 54,5, which was here, which is Q2. So you will let's start with the lower quartile here. The lower quartile, how many numbers are we left with? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's calculate 4 both sides. 1, 2, 3, 4. Okay, as well as 1, 2, 3, 4, making 48, the lower quartile, Q1. Okay, let's do the same thing even there. We have 1, 2, 3, 4. Okay, let's start. 1, 2, 3, 4. So this got the will be, or upper quartile, Q3 will be 63. So already we have the upper quartile is 63. We also have the lower quartile as 48. So the questions at 2.4.3, the upper quartile, which is Q3, the upper quartile will be 63. At 2.4.4, the lower quartile will be 48, just as we have calculated. Then we go to 2.5. At 2.5, they want us to calculate the interquartile range. The interquartile range, guys, this is what I want you to understand in terms of the interquartile range. 2.4.5. The interquartile range, it's IQR interquartile range, which is the difference between the upper quartile and the lower quartile. So meaning that it's going to be 63 minus 48. What is that? That will be 15. It's going to be 15. That's that's the case in this case. That's how you should work it out. Let's go to this beautiful question 2.5. Do the data containing outliers use the formula to explain whether the data contain outliers or not. So the formula, guys, for an outlier, it's going to be Q1 minus 1,5 multiplied by IQR. Meaning, guys, this is what we're going to do. Remember, our Q1 was given as 48, so it's going to be 48 minus 1,5 multiply by our QR, which is 15. We have calculated the 2.4.5. So when we punch that, 48 minus 1,5 times 15, that gives us 25,5. Okay, so this is the range that we are working on. Q3 as well here, minus 1,5, which is the upper quartile, minus 1,5 multiplied by IQR, which we calculated. So we know that Q3 is 63 minus 1,5 multiplied by 15. When you punch that in the calculator, Q3 minus 1,5 multiplied by 15, we get how much? It's 85,5. So is there any data that lies between this range, 25 to 85,5? In this data, there's none. There's no 25, and there's also not. They do not lie. None of the data, none of the above values lie. Fall below, none. So we could just say none of the data fall within this range, within this specific range, range. You'll write properly. So none. So there's no outlier in this case. Okay. Right. So let's go to 2.6. Which is the measure? Which is the better measure of deception for this data? The standard deviation or the interquartile range? In my view, guys, it will be the interquartile range at 2.6. At 2.6, it will be the interquartile range. Interquartile range. I'll explain why. Because there is less affected. The range is less affected by the extremes in this case. So we could say in the interquartile range, the range is less affected by the extremes, or outliers, or unlike the standard deviation in this case, right? So that's how it should be. Guess now we can visit 2.7. We are at the peak. We are now about to finish. So use the intervals, for example, blah 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 and so on, to construct a frequency table. So of 20 students who were timed in effort to complete an F1 concession for certain module, the frequency table must include a tally column and a cumulative frequency. Well, that will be easy to work it out. Let's put that into practice. So to construct a histogram at 2.8, right, use a ruler, guys. Mine will be something else. 5, 10, 15, 20, 25. This is the y-axis and this is the x-axis. So we follow the interval that was at 2.7. So we have 40 to 49. 40 to 49 is 6, so it's somewhere here, meaning that my histogram will be somewhere here where there's 6. We'll say 6. Then the other one, 50 to 59, is 14, so closer to 15, so it's gonna be somewhere here. Then what follows, it's 19, closer to 20. So remember, this one, it's gonna be 50 to 59. Remember, this is for 40 to 49. Then that follows is 60 to 69. 60 to 69 is what then? It's gonna be 19. So that's why I say it's closer. It's closer to 20. This is the interval that falls here. Then we have 80 to 89. which is 1. So it's somewhere here. So 82. No, I'm wrong. It's 8 to 89, it's 20. So it should be somewhere. It's here exactly. Okay, this is the interval that follows. So this is going to be an interval, and this is going to be a cumulative frequency. So this is how you can work out your histogram in this case. But use a ruler, guys, for accuracy, and scale, proper scale, right? So that's how it should be at 2.8. At 2.8. So let's go to 2.9. With reference to the given stem and leaf and histogram in your answer to question 2.8, in what way stem and leaf plot similar to histogram? My view is that both of them display display distribution of data. Yes, in a simple stem, they display the distribution of data, whereas histogram shows frequency of plot, and stem and leaf plot or stem and leaf diagram shows specific range. It shows the individual values, unlike histogram. Yes, that's how you can answer 2.9, right? So let's go to 2.10. At 2.10, guys, they want us to draw and labeled a box and whisker diagram to illustrate the deception of times in seconds who were timed in their efforts to compare an F1 concession task for a certain module. So in this case, we will have a scale according to our data. Remember, we have our data. According to our data here, we have 41. That's the lowest. So we could just say we can go in tens. 10, 20, 30, 40, 60, 80, 100. That will be our scale. So the lowest, the minimum, when you draw a box and whisker diagram, must have 5 number summary. 1 is the minimum number, then Q1, followed by Q2, followed by Q3, then the maximum number. That's how you can plug this. So the minimum number in our data set, it's going to be 41. And we have calculated Q1. Remember, our Q1 was 48. Q2 was 54.5. Q3 was 63. And the highest number, the max value, is 80. Then we need to plug this into this graph. We have to plug this graphically. Let's start with 41. 41 is somewhere here. So that will be our minimum. Put the dots there. So this is the min. Then we have Q1 is 48. Somewhere here. Q1 is 48. Then 54, my scaling. It's scaling. It's not a proper one. Let me just create my own. I'll just plug in whatever that is needed to be plugged. Let's start with 41. 41 will plug our minimum. Then we'll have 48, where we are going to plug our Q1. And then 54.5. So we are going to have, sorry for that, it should be like this. Okay, this is our Q1, and this is our min, and this is Q2. Then we have Q3 is 63. Then we have 80 as maximum. use a ruler. Yours will be much accurate. So this is how you can draw a box and whisker diagram. You must have 5 number summary for you to draw it. Hope you've learned a valuable lesson when you're working with data handling, and I would like to wish you all the best in tomorrow's exam. Do not forget to subscribe if you're new to this channel. Let's grow, and remember, we love you.